Rate at which rainwater flows in a drain pipe is modeled by the function r, where r of t is 20 sine of t squared over 35. Cubic feet per hour, t is measured in hours from 0 to 8. Pipe is partially blocked, allowing water to drain out the outer end of the pipe, modeled by that equation in cubic feet per hour. This is a tough question. We're going to spend 3 days on these type of questions because they are more challenging. I gave you the first two, which are position, velocity, acceleration, and then area and volume. Those should be in your hip pocket. Those should be ones like, you know what, I may not get a 9, but at least I got a shot at getting a 4 or 5 on them. Like, at least I remember some of the content. These ones are a little bit more challenging. A lot of this is going to feel new today, which is why we're going to spend 3 days on it instead of 2. Okay? The question is A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? Now, look at what you're given. Are you given the amount of rainwater that's coming in, or are you giving the rate at which it's coming in? Rate. And when we're given rates, what do we do to find the amounts? Antiderivative, you set up the integral. Very good. So let's do that. Okay, so we got the integral of the rate what's our time period? Okay. So, can I use my calculator on this one? Yes, so take it out and use it. Hey, when you turn your calculator on, you're using sine. You need to make sure mode you're working in, radians. Going to y equals, we type in. I have the function already typed in. We press enter on that and take the other one off. I have it typed in. What do I press? So I can calculate. Number. Lower limit. Upper limit. 7657. I have to go out to 3 decimal places. I've got 0. What is my measurement in? What am I trying to find? Cubic feet. This is an actual amount. If you notice, I've written the title of this area collection, otherwise known as the fundamental theorem of calculus. This is complex stuff, okay? But this is fundamental to what calculus does. We accumulate things when we're given a rate function, so we get that 76.50. Okay? We'll look at B. B says, is the amount of water in the pipe increasing or decreasing at time equals 3 hours? We could just take a guess, and if we got it right, they would give us a point, maybe. But we have to come up with something to justify our answer. So let's think about it. We got this pipe, and what do we have in the middle of the pipe? And a blockage, right? And so you got water coming in at a certain rate, and then you have water draining at a certain rate as well, okay? So who can tell me, how would I determine if the amount of water is actually increasing or decreasing? Thank you. Subtraction. The amount at which it's coming in minus the amount that's going out. If it's positive, it's increase. If it's negative, it's awesome. Way to go. Didn't get that second hour, but you guys are smarter, I guess. So I do r of t minus d of t. Okay? So I take r of 3 minus d of 3. So in your calculator, you're going to type both of these pieces in. So I go into my y equals. And I got 5.0 0.0864 minus 5.4. So is it going to be positive or negative? Negative 0.3136. So therefore, the amount of water is there we have it. This is your justification, your R of t minus d of t. Part C. At what time is the amount of water piped at a minimum? What does it mean to be at a minimum? Think about your learning of calculus. Where does the minimum value occur? Very good. So you're looking for where f prime changes from negative to positive. That's what we thought back in the day, right? Now, go get some brain food. We'll come on back. Okay, we pick up with problem C. Problem C says, at what point is the water in the pipe at a minimum? You guys told me that the minimum occurs when the derivative goes from negative to positive. Tell me, okay, as you look at the functions that were given, are we given the derivatives or are we given the originals? Which is it? Are these rate functions or position functions? Rate functions. So therefore, we are given the derivatives. So all we are looking for is where does R of t minus d of t change from negative to positive. If I turn my calculator on, this is something that could save you time. I go into y equals, is this R of t or d of t? R of t. How about the next one? So what I am going to do is I'm simply going to take off the equal signs, and I'm going to do y sub 1 minus y sub 2. Now again, I'll show you how I calculate that. I press variables, I go to y variables, and I grab y1. Minus variables, y2. And so you can see that that's the piece that I have. So this refers to the rate at which water is accumulating. Does this graph ever go from negative to positive? How would I find that spot? So I can calculate number 2. Yep, 0. And so I go to the left bound, which we are going to declare right here. And we'll go to the right bound, which we declare right there. And we get 3.272. And what is the measurement of time in? Hours. Again, this is the rate function. We are given the rate function. We didn't need to take the derivative. Finally, question D. Question D is challenging for you to set up. Once you see it once, you'll be more likely to get it when we look at these problems in the future. But don't be surprised if you're a little confused when we look at it right now. So the pipe can hold 50 cubic feet of water before overflowing. How much does it have at time 0? 30. So how much more can it get? 20. How would we set up, so it says for time greater than 8, water continues to flow in and out of the pipe at given rates until the pipe begins to overflow, right? But do not solve an equation involving one or more integrals that gives the time w when the pipe begins to overflow. So I want to know when there's a total amount of 50, right? So what do I start with? How much do I start with in the pipe? 30. What do we do to figure out accumulation? How much is accumulated? What do we do to figure that out? What operation in calculus do we use to figure out how much it's antiderivative? So this is something that we've talked about before, and we'll try to bring it back again. But if we want to know how far we've traveled, we take the antiderivative of the velocity function. The antiderivative of the rate function will tell us the position function. And so same thing here. This is our rate function. Taking the antiderivative will tell us how much it has accumulated or gathered over that time. So your key word here is this, really. It can hold a total amount. So we are wondering when it's gathered that much. Gathered is the integral. At what time does it start gathering water? 0, and we are wondering at what time it actually reaches 50. So here's the important stuff I need you to see. Number 1, you see that this is your rate function. That told us the rate at which it's coming in and leaving, overall rate. The antiderivative tells us then the accumulation. Kind of like if it was a velocity function, the antiderivative would tell us total distance. What does this represent? Starting, what does this represent? And these represent the time. Yep, bounds are the time, okay? So that's a challenging problem. Let's try an easier one that will help you set up for your homework a little bit better. This one, you are not allowed to use a calculator on. Okay. Here we go. This problem is nicer. I think you guys will appreciate this one. Johanna jogs along a straight path. Johanna's velocity is given by the differentiable function v. So are we given the velocity function or the position function? Velocity function. So we are given a derivative. That's what you need to think about, okay? Selected values of v of t are measured in minutes. V of t is measured in meters per minute. It's given above. Use the data in the table to estimate v prime of 16. What does v prime mean? The derivative. Now, derivative is the same idea as slope, right? So how would I find the slope at time equals 16? What would you do? 240 minus 200 over 20 minus 12. That's something, you guys, I know that there's some parts that on here that are difficult. That's becoming more one of those non-negotiable pieces. I need you to be confident in that, okay? That if you want to know v prime of 16, it's approximately equal to v of 20 minus v of 12 divided by 20 minus 12. Because the derivative is slope. We can't find the exact derivative because we don't have a function, but we have a table that we could use to estimate it. Kyle says take 240 minus 200 over 8, and I get 5. What is my label? What's the derivative of velocity? What is the derivative of velocity? Yes, but if I'm speaking in general, velocity, the derivative of velocity gives us acceleration. And so we will be 5 meters per minute squared. So understand that if you're looking for the derivative of velocity, you must list it as acceleration with the appropriate unit. Okay? They would take a point off if you did not have the squared unit for acceleration. I will score it as the AP exam scores it. B. Using correct units, explain the meaning of this definite integral in context of the problem. What does absolute value tell us? Does it Distance. Distance or displacement? Distance. So this is nice and easy. The integral from 0 to 40 of the absolute value of v of t dt is the total distance Johanna has traveled from time equals what? 0 to time equals 40. And is it minutes? Okay, so again, when I first did a problem like this and I scored myself, I wrote total distance. I didn't say anything about the 0 to 40. You have to make a statement about the 0 to 40. Okay? The second part of the question is to approximate the value of that integral by using right Riemann sums or subintervals. So as I look at the table, I want to create 4 intervals. 1, 2, 3, 4. How do you find the area of rectangles? Base times the height. What's the base of the first rectangle? 12 times what is the height? 200 plus what's the base of the next rectangle? 8 times what's the height? 240. What's the next base? What's the height? Now, do I use negative 220 or do I use positive 220? Why? Because we're doing absolute value. When I did this test 3 days ago, I got 8 out of 9 because I did not do the absolute value of that. I got that part wrong. Okay? So it happens. You make mistakes. I forgot to do it. You'll make mistakes too. So we go 220 plus, what's the last width? 4 times, what is it? 150. Are you allowed? Oh, it's 16. I don't know. 12 and sim 4. Okay, 16. It's all right. Okay, so do we get a calculator? No. 12 times 200 is 2,400. Plus 8 times 240. I don't know. I got to figure it out. That one's 880. Because I don't know any other way you do it. You know, you just kind of got to do the math, right? Or the arithmetic. So I got to add these up. The 2,400 and the 2,600 make. Did I do that right? Zero, zero, 3, 9. Yeah, it should be 2,400, right? Sorry about that. So we have 4,800 plus 1,920 plus 880. $7,600 what? What are we finding? We're finding a distance, aren't we? So it's meters. Good. C. So it goes position, velocity, and acceleration. So velocity is the derivative of position. Acceleration is the derivative of velocity. The antiderivative of acceleration is velocity, and the antiderivative of velocity is position. Acceleration is the derivative of velocity. And that will come in handy for question C. C says Bob is riding his bicycle along. I'll go up here for anybody watching YouTube. Bob is riding his bicycle along the same path. From time equals 0 to time equals 10, Bob's velocity is modeled by that function. T is measured in minutes, and B of t is measured in meters per minute. Find Bob's acceleration at time equals 5. I will fully admit, you guys, that this problem, I would be disappointed if at least 2/3 of the people on the exam did not get this correct. This is that easy of a problem. What am I looking for? How do I find acceleration given this? Take the derivative. So, acceleration of t is equal to b prime of t. What is the derivative? And what are we plugging in? So a of 5 is equal to 3 times 5 squared minus 12 times 5. 5 squared is 25 times 3 is 75 minus 60 is 15 what? Meters per minute squared. Wait, is that? Yeah. And finally, part D. Based on the model B from part C, find Bob's average velocity during that time. This is not a difficult problem as long as you remember this one piece. I just introduced this to you 4 days ago. We're going to see if you remember it again. They're asking for the average velocity, okay? That's the average value. Remember, average value of a function over a given interval, we do this. We do the integral from a to b of the function, but we multiply by 1 over b minus a. Remember that little formula we did a few days ago? The key word here that you need to remember is it's asking for the average velocity, or the average value of Bob's velocity function. So this is all we need to do. 1 over, what's the time interval? 0 to 10. So it's 1 over what? 10 times, what's his velocity function? T to the third minus 6t squared plus 300 dt. So I have 1 over 10 times, what's the antiderivative of t to the third? Minus t cubed plus plug it in. What's 10 to the fourth? 10,000. 10,000 divided by 4, 2,500. Remember, you don't get to use a calculator, so this is what you got to figure out. 10 to the third times 2 plus 3,000. 1 over 10 times 2,500 minus 2,000 is 500. Is 3,000 is 3,500 times a tenth. 150 what? It's the average value of his velocity. Meters per minute. It's asking for the average value of his velocity, so we are finding a velocity, so that is our measurement. Okay, so there you have it. Okay, these are more involved, and so we are not going to just take 2 days. We will be taking 3 days. What I would like you to do is a calculator problem I'd like you to try problem 3. I just want you to know this is not an easy problem. It would be difficult to score 9 on this problem. But I think it's reasonable to say, hey, I think I could get a 2 or a 3 on this as I try. Okay. So, note, so the grass clippings. So problem 3, which is problem 1 from 2014. Grass clippings are placed in a bin. They decompose. Give that one a shot. YouTube, we'll see you tomorrow.